Lightning, an electrifying natural phenomenon, strikes the Earth's surface about 100 times every second. But have you ever wondered how and why it happens? Imagine this, a bolt of lightning, 5 times hotter than the sun, zipping through the sky at a staggering 60,000 miles per second. It's a spectacle that captures our attention and curiosity. Lightning is a massive discharge of electricity accompanied by a brilliant flash of light and a loud crack of thunder. The exact process of how it forms is still a topic of scientific debate, but what we do know is that it's a complex interaction between the Earth and its atmosphere. Did you know that the United States alone experiences about 20 million lightning strikes each year? Or that a single bolt can carry up to 1 billion volts of electricity? These are just a few fascinating facts about this incredible natural phenomenon. In this video, we will unravel the science behind lightning and thunderstorms. Thunderstorms are the cradle where lightning is born. But what creates a thunderstorm? Let's unravel this atmospheric phenomenon. Thunderstorms begin with the sun. Yes, that's right, the sun. Its intense heat warms the ground and causes the air above to heat up as well. This warm air rises, creating an updraft. As it ascends, the air cools and forms a cloud. But not just any cloud, a special type of cloud called a cumulonimbus cloud. Now, these aren't your everyday fluffy white clouds. Cumulonimbus clouds are towering giants, stretching high into the atmosphere, sometimes reaching heights of over 12 kilometers. Here's where things start to get interesting. Within this cloud, there are countless tiny water droplets and ice particles. These particles are constantly in motion due to the updrafts and downdrafts within the cloud. Warm air continues to rise, carrying water droplets upwards. As they ascend, these droplets collide with colder particles, causing them to freeze. The process of freezing releases heat, which makes the surrounding air warmer and causes it to rise further, creating more updraft. This continuous cycle leads to the formation of larger and larger ice particles. Now, let's talk about electricity. You see, during these collisions, electrons are knocked off of rising particles and captured by falling ones. This process creates a separation of electrical charges. The top of the cloud becomes positively charged, while the bottom becomes negatively charged. This buildup of electrical charges is what sets the stage for a lightning strike. It's a bit like a giant battery, with positive and negative ends. And, just like a battery, when the difference in charge becomes too great, it's discharged. In this case, the discharge is a bolt of lightning. So, to sum it up, a mixture of warm and cold air, the sun's heat, water droplets and ice and some physics magic, all come together to create a thunderstorm. And within this storm, the conditions are just right for the birth of lightning. When the storm cloud is charged, the stage is set for a lightning strike. Lightning is a massive discharge of electricity, but how does this intense energy build up and release? To understand the birth of lightning, we must first look at the thunderclouds. Within these clouds, there's a flurry of activity. Ice particles and water droplets constantly collide, and through these collisions an electric charge begins to build. Now, imagine the thundercloud as a colossal battery. The top of the cloud becomes positively charged and the bottom becomes negatively charged. This is the result of lighter, positively charged ice crystals being carried upwards by the air currents, while heavier, negatively charged particles sink to the bottom. The ground beneath the cloud also becomes positively charged, mirroring the cloud above. This separation of charges sets the stage for one of nature's most spectacular displays. But, for the grand performance to take place, we need a path. This is where the stepped leader comes into play. The stepped leader is a channel of ionized air. It begins at the cloud base, reaching out tentatively towards the ground, in a series of steps, each about 50 yards long. While invisible to the naked eye, this leader is the trailblazer, creating a pathway for the lightning bolt. As the stepped leader nears the ground, an interesting phenomenon occurs. The positively charged objects on the ground reach upwards, creating a streamer. When a streamer and a stepped leader meet, the circuit is completed. Now we have a path, and the stage is set. The negatively charged particles rush down this path towards the ground, in a dazzling spectacle we know as the lightning bolt. This bolt travels at a staggering speed of 60,000 miles per second, and can reach temperatures hotter than the surface of the sun. This all happens in a blink of an eye, but the result is a breathtaking display of raw, unbridled power. The energy released in this process is immense, enough to power 100 million light bulbs. And with a crack, the bolt of lightning is released, illuminating the sky. Thunder is the soundtrack of a storm, the rumbling echo of a lightning strike. But why does lightning produce this sound? Now that's a question that piques our curiosity. Let's delve into the electrifying world of thunder. So thunder is the result of the rapid expansion and contraction of air surrounding the lightning bolt. As the bolt streaks through the air, it heats the air around it to a staggering 50,000 degrees Fahrenheit, almost 5 times hotter than the surface of the sun. This abrupt extreme heat causes the air to expand rapidly, creating a shock wave that moves through the air, forming a sound wave we know as thunder. But why does this sound seem to rumble? Well, the sound waves produced by the lightning bolt's path are not uniform. They are emitted from different points along the bolt, reaching our ears at different times. The closer sound waves reach us first, followed by the ones further away, creating that distinct rolling thunder we often associate with a stormy night. Additionally, these sound waves can bounce off the Earth's surface and other atmospheric layers, further contributing to the rumbling effect. This is why, even when the storm is miles away, we can still hear the distant rumble of thunder. So the next time you hear a thunderclap, remember it's the echo of a lightning strike. Lightning is not just a spectacular show of nature, it's a powerful force with significant impact. As we delve deeper into the realm of lightning, we come face to face with the incredible effects it can have on our world. Let's start with forest fires. Each year, thousands of fires are sparked by lightning strikes. These fires can decimate vast tracts of forest, impacting wildlife habitats and contributing to global warming by releasing large amounts of carbon dioxide into the atmosphere. Moving on, let's consider the structural damage caused by lightning. When a bolt strikes a building, the results can be catastrophic. The intense heat can cause materials to expand and explode, leading to structural damage, fires, and even total destruction. But perhaps the most profound impact of lightning is on human life. Every year, hundreds of people around the world are struck by lightning, and while some survive, many are left with lifelong injuries or, tragically, lose their lives. Lightning can also impact our technological world. It can cause power outages, fry electrical systems, and disrupt communication networks. Despite these dangers, lightning also plays a vital role in our planet's nitrogen cycle. It helps to naturally fertilize the soil, contributing to the growth and nourishment of the world's flora. Lightning reminds us of nature's immense power and the importance of respecting it. It's not just a marvel to observe, but a powerful force that shapes our world in ways both destructive and beneficial. The science of lightning is as fascinating as the phenomenon itself. Let's take a moment to look back at what we've uncovered in our journey through the electrifying world of lightning and thunderstorms. We started our exploration by diving into the mysteries of lightning, a dazzling natural spectacle that has intrigued humans for centuries. Remember, lightning is a powerful electrical discharge created during a thunderstorm. This discharge results from the energy buildup between positively charged areas and negatively charged areas. Then, we moved on to the making of a thunderstorm, a key player in the birth of lightning. The process begins with the heating of the Earth's surface, leading to the rise of warm, moist air. This creates an updraft, which in turn forms a cumulonimbus cloud. As the cloud grows and reaches colder air, ice particles and supercooled water droplets begin to form. These particles collide and create an electrical charge,